This is lesson 7.5, rational exponents and radicals. Your objective is to rewrite expressions involving radicals and rational exponents. With a radical sign, the index indicates the degree of the root. For a cube root, the degree is 3. If there is no index, the degree is 2, which means square root. Remember, this is called the radical symbol, and the number inside is called the radicand. Recall what you know about square roots. Since 5 to the second power equals 25, you know that the square root of 25 equals 5. We also know that 25 to the 1/2 power equals 5. So using the transitive property of equality, we can conclude that the square root of 25 is equal to 25 to the 1/2 power. Similarly, the cube root of 8 is equal to 8 to the 1/3 power. You can simplify radical expressions by finding like factors, just as when simplifying powers with rational exponents. Here's a problem. We have the cube root of 125. Well, the cube root of 125, well, we know that 5 multiplied by itself 3 times will give us 125. So we can rewrite this as the cube root of 5 times 5 times 5, which will give us 5. The fourth root of 16, we can also rewrite that as 16 to the 1/4 power. Well, we know that 2 multiplied by itself 4 times will give us 16, so the fourth root of 16 equals 2. You can also write expressions that have rational exponents like 2 over 3 in radical form. So here we have 8 to the 2/3 power. We separate the numerator and the denominator by multiplication, so we have 2 times 1 over 3. Then we take the 8 to the second power and raise it to the 1/3 power, because when we're raising a power to a power, we can multiply the exponents. And now with that 1/3 power, we can rewrite that in radical form as a third root of 8 to the second power. Similarly, we can also do 1/3 times 2, and 8 to the 1/3 power is the cube root of 8. So basically, we're taking the cube root of 8 and raising it to the second power. These are both equivalent. Equivalence of radicals and rational exponents. If the nth root of a is a real number and m and n are positive integers, then a to the 1 over n power is equal to the nth root of a, and if we have a to the m over n power, that is equal to the nth root of a to the m power, or we can think of it as the nth root of a, that quantity, to the nth power. So we're converting into radical form. We have 12 times a to the 2/3 power. Well, the 2/3 power is only applying to the a, so we leave 12 alone. And a is being raised to the second power, but it's also being raised to the 1/3 power. So we can take the third root of a squared. Here we have to be careful. Here we have the quantity 64a being raised to 4/5. Well, since we have 64, we can split that up as 32 times 2. And the reason why we want to do this is because our denominator is 5. That means we're looking for the 5th root of a number. And there is no 5th root of 64, at least not an integer, so we need to find a number, a factor of 64 that does have a 5th root. So we know that the 5th power of 2 is equal to 32. So we're going to rewrite the 64a as 32 times 2a. Now we'll raise each of these numbers to the 4/5 power. So we have 32 to the 4/5 power and 2a to the 4/5 power. Well, we know that 2 to the 5th power equals 32, so we'll replace that. That being raised to the 4/5 power means I'm multiplying the exponents, so 5 times 4 over 5 will just give me 4. So now I have 2 to the 4th power replacing this entire thing, which is just equal to 16. For the other factor, I have 2a being raised to the 4/5 power, so I take each of those inside. I take the 5th root of that quantity being raised to the 4th power. So I have 2a raised to the 4th power, and I'm taking the 5th root of that. How do I write the 5th root of b to the 3rd power in exponential form? Well, b to the 3rd power, and then the 5th root means that I'm really raising this to the 1/5 power. So I have b to the 3rd power times raised to the 1/5 power, and I just multiply the exponents, and I get 3/5 as my power. Here I have the cube root of 27 and d to the 5th power. I can rewrite this as 27 times d to the 5th power, that quantity raised to the 1/3 power. Well, I can separate the factors. 27 to the 1/3 power is equal to 3, because that's the cube root of 27. And then d to the 5th power times to the 1/3 power, I just multiply the two numbers, and I get d to the 5/3 power. Well, let's simplify the cube root of 27. The cube root of 27 basically is the same thing as 27 to the 1/3 power. So we need to think what number multiplied by itself will give us 27, and that will equal 3. Here we have 5 times x to the 1/3 power. We want to write this in radical form. The exponent only applies to the x, so I leave 5 alone. And since it's the 1/3 power, that I'm taking the cube root of x. Let's write this radical in exponential form. I have s to the 2nd power. Basically, this is being raised to the 1/3 power. And since the power being raised to a power, I just multiply the two numbers, and I have s to the 2/3 power. Here I have 12 times the cube root of x to the 4th power. 12 stays the same. And then, if you notice a pattern, the root index actually just becomes the denominator, and the power becomes the numerator. So if I do x to the 4/3 power.